The intent of this training video is to demonstrate the proper technique to be used during the Coldhead replacement process on a GE LCC superconducting magnet. The demonstrations within this video were performed in a factory environment. The magnet is not at field. This procedure uses helium gas obtained from the magnet. For safety reasons, 2 service personnel must perform this procedure. All individuals involved in performing the Coldhead replacement must be thoroughly familiar with the safety procedures involved. Service personnel must wear personal oxygen monitors during this procedure. Before beginning this process, review the procedure. Manuals and electronic media are updated regularly. Make sure you are working with the latest information. This demonstration follows the Coldhead replacement procedure found in the GE 1.5T and 1.0T LCC Active Shield Magnet and Cryogen's Subsystem Manual. To minimize false alarms, disable the magnet monitor master alarm at this time. This can be accomplished by disabling the master alarm on the SHEM. First, log on to the SHEM from the console or your laptop. Then go to Configure, then Alarm, select the radio button to turn off the master alarm, then select Save. Coldhead shield temperatures should be monitored using the magnet monitor and laptop under current values. If your magnet is equipped with a Magnet Monitor 3, you can disable the master alarm by putting it in the service mode. This is accomplished from the front panel. Select Service Mode and then input the service password 2513. After the replacement procedure, remember to take the MM3 out of service mode or enable the master alarm on the SHEM. In preparation for the Coldhead replacement, all kits should be ordered in advance. Make sure you have all the tools and equipment necessary to perform the task prior to beginning the procedure. Each kit should be carefully inspected for defects and/or missing parts. It is important to verify that the heater works prior to removing the Coldhead. A simple check of the light bulb is all that is required to check the heater. In preparation for this process, the top cover, front GE logo cover, and blue decorative enclosure covers are removed. Service personnel should make sure to clear the area of any individuals not directly involved with this service process. It is also a good idea to inspect the entire work area before you begin and establish a safety zone to work in. Also, designate a removal path for the Coldhead with respect to existing magnetic fields. The service platform should be assembled outside of the magnet room and then placed in the Coldhead service position. All safety rails should also be installed. The magnet pressure must remain under 4 psi for the replacement procedure. This helps eliminate any ice buildup in the recondenser. Monitor pressure throughout the Coldhead replacement procedure. Pressure should not increase while venting through the heater during the Coldhead change. If magnet pressure is greater than 4 psi, vent the magnet down through vent valve V2. The Coldhead compressor now needs to be shut down. To prevent pressure buildup in the Coldhead, first turn on the Coldhead drive switch on the compressor's back panel. Then, place the drive switch on the compressor's front panel in the off position. Run the Coldhead for only 10 seconds with the compressor turned off to prevent pressure buildup in the Coldhead. Then turn off the Coldhead drive switch and the compressor's main power switch. Next, the Coldhead needs to be removed from the magnet. Open the Coldhead motor shield by removing the stainless steel socket head cap screw in the end of the motor shield. The motor shield will drop down out of the way. The gas lines should be removed as soon as the compressor is turned off. If there are any contaminants in the coldhead circuit, they usually migrate to the coldest area and are trapped in the coldhead. By removing the lines before the coldhead warms up, the contaminants may be removed with the coldhead. Removing the coldhead lines requires the use of 2 wrenches. To disconnect the gas line at the coldhead, first place a wrench on the stationary part of the female coupling. Then use a second wrench to turn the female coupling union nut about 1/8 turn. This will overcome the initial torque required to break the connection. Make sure the male coldhead connector does not rotate when disconnecting. Monitor the male coupling on the coldhead while disconnecting. Make sure the bulkhead jam nut is secure and the male coupling does not rotate when removing the gas line. Now remove the coldhead power connection. Then remove the coldhead diode connector. The vacuum equipment now needs to be assembled. During the assembly of the vacuum equipment, apply a light coat of silicone grease to the O-rings. This will ensure a tight seal. Never bring entire kits into the magnet room. Assemble as much equipment as you can in advance, connecting them to each other as you go. In this demonstration, we are showing the use of atmosphere as a purge gas. Make sure you place the desiccant filter out of the magnet room and run the purge line to the magnet. The magnet room atmosphere may have a high helium background. The purge gas should be as free of helium as possible. By placing the desiccant filter outside the room, you will lower the helium background of the purge gas. Next, attach the vacuum operator equipment to the magnet. Make sure the O-ring on the seal-off operator has a light coat of silicone grease. Tighten the compression nut on the seal-off operator with a wrench. Most vacuum leaks occur at this connection. After the vacuum operator equipment is attached to the magnet, then connect the vacuum hose to the assembly. This will ease in the assembly of the equipment. Next, connect the digital vacuum gauge. Then connect the purge line that is connected to the desiccant filter outside the room to the vacuum operator assembly. After all the equipment is connected and attached to the magnet, it needs to be tested for proper seals and operation. This can be accomplished by leaving the seal-off operator closed and opening the black handle to pull a vacuum on the assembled fixture. Typically, you should reach a vacuum of approximately 20 millitorr or less. If vacuum is stable, then close the black handle valve and continue. If the gauge rises greater than 200 millitorr over 30 seconds, suspect a leak. If a leak is suspected, recheck the pump out port and line connections. Remove the purge line running to the desiccant filter. Helium gas obtained from the magnet is used to backfill the coldhead sleeve prior to coldhead removal. Then attach the line from the vacuum operator assembly to the shim lead Nupro valve. Remove 2 opposing coldhead bolts. Remove the Belleville washers from the removed bolts. Caution: Belleville washers are magnetic. Reinsert the bolts without the washers and tighten them finger tight. Then back them off about 1/4 inch. These 2 bolts ensure that the coldhead can be contained when gas pressure is applied. Now completely remove the remaining 6 bolts. Push in and rotate the black handle of the seal-off operator clockwise to engage the plug in the pump-out port. When the handle is engaged, pull the handle out to open the pump-out port. Open the green Nupro valve on the vacuum assembly. Then slowly open the shim lead green Nupro valve. Slowly introduce helium gas into the sleeve. The helium gas will pressurize the sleeve, driving the cold head out evenly. Watch for movement of the cold head. It will separate from the magnet at the flange. Watch the gap. If the cold head does not release, then try slightly rotating it loose. If it still will not release, a large non-ferrous screwdriver may be used to pry it loose. Install the insertion tool carriage bracket. Make sure to tighten the compression screw on the carriage bracket so the cold head does not slide out. Now remove the 2 remaining bolts holding the cold head in the sleeve. The cold head is now ready to remove. The temperature of the cold head will be at 4 degrees Kelvin, so cryogen gloves must be worn to handle the cold head. Release the compression screw on the extraction rail and slide the cold head from the cold head sleeve. Remove the cold head from the room using a pre-planned route to minimize magnetic field exposure. As soon as possible, install the cold head sleeve heater assembly. This will keep the sleeve free of contaminants and ice. Close the green Nupro valve on the vacuum assembly and connect the helium supply line to the heater assembly. Make sure that the helium gas is flowing and it continues to circulate around the heater element within the sleeve. Verify the heater is turned on by checking for light on the heater assembly. Periodically monitor the magnet pressure. It should not exceed 4 psi. It should be dropping from the original level, not rising. Helium gas is flowing through the heater. While heating the sleeve, monitor the recondenser SI410 diode. There is a possibility of quenching the magnet if its temperature exceeds 285 degrees Kelvin. All supplies should be laid out and available prior to the cold head prep. Rubber gloves, clean towels, tape, Scotch-Brite pads, and alcohol are not supplied with the cold head. They should be ordered ahead of time. The cold head box has been modified to help assist in prepping the cold head. The top insert has holes machined to hold the cold head upright while prepping the cold head. The indium gaskets, getter, gloves, and O-rings should be inspected and set aside. The new cold head should also be inspected to ensure there has been no damage to the contents in shipment. Use the insert to hold the cold head for preparation. The cold head surface now needs to be prepared. To obtain a good vacuum in the sleeve, the cold head must have all contaminants removed from its surface. All the old indium and the black marks caused by oils have to be removed. The FE should wear rubber gloves during the cleaning process to help eliminate oils from his skin contacting the cold head. First step is to wipe the cold head surface completely down with alcohol. Remove all vacuum grease from the O-ring area. Next, take a lint-free cloth or Kim wipe and tuck it into the flange. This will help catch the dust from the Scotch-Brite pad. Then take a Scotch-Brite pad and polish all the copper surfaces. You want the copper to appear like a shiny new penny. Copper is a very good material for thermal transfer, but it is also very porous and can hold contaminants that can outgas over time and degrade the vacuum in the sleeve. By polishing the surface, you can help ensure a lasting proper vacuum. After the cold head is polished, wipe it down with alcohol again. Also make sure to clean up any green dust between the first and second stage that may have fallen in the gap. Then take a small screwdriver and clean the hole on the side of the cold head. This hole is used to pull a vacuum on the second stage. If it is clogged, you will not pull a good vacuum and the coldhead efficiency will be degraded. Apply a very thin coat of vacuum grease to the O-ring. Use rubber gloves to apply the grease. The proper way to apply the vacuum grease is to roll the O-ring through your fingers. Do not pull the O-ring through your fingers while applying the grease. This will stretch the O-ring and may cause it to get nicked during installation, which could cause the vacuum to degrade over time. After a very thin coat of vacuum grease is applied to the O-ring, then install the O-ring to the coldhead. Make sure that the O-ring grease does not contact the other surfaces of the coldhead. At this point, you should change to clean cotton gloves that are provided. This is a very important step. You do not want any grease from the O-ring or oils from your skin to contaminate the surface you just cleaned. Only handle the indium gaskets with the cotton gloves provided. Place the large indium gasket on the large copper first stage heat station of the coldhead. Secure the gasket to the surface of the station by putting pressure on the gasket, forcing indium into the small notches in the surface of the station. To prevent the large gasket from falling off the coldhead during installation, use 0.125 inch by 1 inch strips of aluminum tape. Place the tape over the notch you just formed. Then take the 0.25 inch wide tape and wrap the outer diameter of the first stage with a gap left at the second stage vent hole. Make sure the tape does not ride up and cause interference with the indium gasket contact with the first stage. Make sure the second stage vent hole is not covered. Do not use permaseal tape on the first stage. Next, open the second stage gasket and inspect the wire in the mold. Make sure the indium wire is positioned correctly in the mold. Install the second stage indium wire gasket by placing the entire wire mold on the top. Hold the mold with 2 fingers on each side to flip onto the coldhead. The direction of the wire should be parallel to the coldhead motor center line. Carefully pull the indium wire over the edge, securing it with the tape. All wires should make good contact with the top face of the second stage. Take a hard object and press down on the tape edges to make sure it has a good contact with the copper. This will assist you when you have to replace the coldhead in the future. Finally, install a getter bag to the side of the second stage with 0.25 inch permaseal tape. The bag should be installed directly over the RUO diode at the tip of the second stage. Only 1 getter bag is required. Apply a second row of tape to the bottom of the bag. Make sure the bag is tightly secured in place. Next, cover the insert with a clean towel to keep the coldhead clean. The coldhead insertion bracket now needs to be installed. The coldhead replacement kit now includes a new set of Belleville washers. Remove and throw away the 6 old Belleville washers. Make sure not to remove the flat washer. Install 6 new Belleville washers on each of the 8 coldhead bolts. The Belleville washers, over time, wear out and lose their spring strength. This spring action is used to set the right torque on the bolts to properly compress the indium gaskets. They are also used to assist the coldhead in recovering from an outage and keep the gaskets in contact with the sleeve. The Bellevilles are installed in sets of 3. Make sure you have them installed as the diagram shows. Now that the coldhead is ready, the temperature of the coldhead heat stations should be checked. The sleeve must be between 265 and 275 degrees Kelvin to properly insert the coldhead. Once the coldhead sleeve reaches 265 to 275 degrees Kelvin, stop the helium gas flow by closing the green Nupro valve on the shim lead. Then unplug the heater and remove it from the sleeve. Remove all of the old vacuum grease from the sleeve using a lint-free towel and some alcohol. At this time, excess indium should be removed from both heat stations and their surfaces polished. Use the indium removal tool to scrape off any indium left behind by the old Coldhead. A tool may be created by taping Scotch-Brite to one end of the indium removal tool that is long enough to reach both heat station surfaces inside the sleeve. The Coldhead sleeve should now be cleaned of excess indium and polished with the Scotch-Brite pad. Wipe out the sleeve one more time with alcohol to remove any green dust left behind by the Scotch-Brite. The sleeve should be free of frost and the copper surface polished. The new Coldhead is now brought into the room. Remember, use your pre-planned route to minimize exposure to the magnetic field. Next, carefully mount the Coldhead to the extraction tool rail. The Coldhead is carefully inserted into the sleeve. Gently push the Coldhead to just get past the O-ring. Then tighten the compression screw on the rail to hold the Coldhead in place. Install 2 of the hex bolts that have the new Belleville washers. Remove the extraction tool rail and carriage assembly completely. Now install the other 6 Coldhead bolts with new Belleville washers. When tightening the bolts, evenly draw the Coldhead into the sleeve using an opposing cross-pattern technique, turning each bolt a half turn at a time. The Belleville washers will be adjusted to specification later. Do not use vacuum to draw the Coldhead into the sleeve. It is very important to keep the Coldhead square with the flange. Check the flange for an even gap. Continue tightening the bolts as described 1/2 a turn at a time. Use the colored plastic feeler gauges provided to monitor the gap in the Belleville washer to 3 to 5/1000ths of an inch. Repeat this bolt tightening technique until the Coldhead is in place and the gap is between 3 and 5/1000ths of an inch. When the proper gap is obtained, then the blue feeler gauge will no longer fit in the gap, but the green feeler gauge will. Once the proper gap on the Bellevilles is set, then the sleeve will need to be vacuumed down to the proper spec. Connect the purge line that is run outside the magnet room to the vacuum operator. Engage the vacuum pump, then open the black-handled valve on the operator. Evacuate the sleeve space while the vacuum valve remains open. When the vacuum reaches 30 millitorr, close the vacuum valve. Open the service adapter's gas flow valve to allow air from the backfill air hose to flow into the sleeve. When the pressure within the sleeve reaches 1 atmosphere, close the gas flow valve and then open the black vacuum valve. Repeat a total of 10 times. 10 evacuation backfill cycles. When using atmosphere for the vacuum purge gas, it takes at least 10 purges to get the vacuum to the proper level. When performing the last evacuation, let the vacuum pump pull down the sleeve for at least 15 to 20 minutes. You can start connecting the rest of the lines during the last evacuation. Start attaching the helium gas lines. The first connection can be just finger tight. When tightening the lines to make the connection, make sure you tighten the return helium line first. Use 2 wrenches on the final turns, then tighten the supply line. Swing the motor shield back into position. Be careful to not have your fingers by the gap. This is a pinch hazard. Secure it with the screw. Then attach the Coldhead power cable. Then attach the diode sensor cables. The vacuum now should be at or below 20 millitorr. The vacuum must have run for 15 to 20 minutes. Close the vacuum operator valve, then monitor the vacuum. It should hold steady. Push in and rotate the black handle of the seal-off operator counterclockwise to engage the plug in the pump-out port. You will hear the screw start to click once it is released. Now open the green atmosphere purge line to release the vacuum in the operator assembly. This will help keep the plug on the vacuum port. Now pull out the seal-off operator. The vacuum equipment can now be removed. All tools should be carefully removed from the magnet environment. At this time, restore power to the compressor and cold head. Allow the compressor to run for a minute or two and check the gauges to ensure the system is stable. If the yellow light at the rear of the compressor is off, the compressor is running in bypass mode. To correct this condition, allow the compressor to run for 5 minutes. If the yellow light is still off, cycle power to the compressor. Compressor pressure will lower as the heat load decreases. As the cold head starts to cool down and reach the operating temperature, the gap in the Belleville washers will expand. The bolts will need to be adjusted to maintain the proper gap. Tighten bolts as necessary. This readjustment of the Belleville washers should be done approximately 4 times during the first 15 minutes of the cold head's operation to ensure good thermal conductivity between the cold head and the thermal contacts within the sleeve. A final inspection and adjustment of the bolts should be performed. As a final check, after 30 to 60 minutes, turn off the compressor and check the static pressure of the compressor. It should be at 1.65 megapascals. If it is not, follow the procedure to top it off. It's important to make sure that the temperatures are decreasing over the next 30 to 45 minutes. The difference in temperature between the cold head and the recondenser should be less than 0.2 degrees Kelvin. The procedure just seen is very similar to the LCC 300 3.0T cold head replacement process, with one exception. Order and use the 3T cold head service tool in place of the 1.5T cold head extraction tool kit. For details on the setup and use of this service tool, refer to the LCC 300 Magnet and Cryogen's Subsystem Manual. Also, review the MR Signa Excite 3.0T Service Operations and Safety CD-ROM, part number 2406438. It provides an overview of the setup of this tool.